Alright, let's go ahead and find the derivative of cosine of x. Okay, let's go ahead and find the derivative of cosine of theta squared. So we see that the outer function is cosine, and then the inner function is theta squared. And we have to use the chain rule. And here we go. Let's go ahead and practice without drawing the boxes and all that. So let's see, if we just go ahead and do the derivative right here, this is f prime of theta. What we do is we differentiate cosine, and that will give us negative sine. And then the input stays the same, so let's write down theta squared. But we look at the inside and we ask ourselves, what's the derivative of theta squared? And the answer for that is 2 theta. So we multiply by 2 theta like this. So that will be it. This is the derivative. And again, this is the part that we need a chain rule. And if you want to use the box, right, just to kind of guide us along the way, this is how it will look like. The outer function is denoted by little f, and we will just have cosine of a box. And then the inner function is g, which is the theta squared. And now you see, once you break them apart, it's much easier to handle. For this one, when we differentiate this f, we get the derivative of cosine of a box is negative sine of the box. All right? And then if we differentiate this, we get 2 theta. And again, we just put this inside of the box and then we multiply. Have a look. Negative sine theta squared and then multiply by 2 theta like this. And usually we like to have this part in the front, so finally I'll just put that down in the front. So we have negative 2 theta and then sine of theta squared. And this right here will be it. However, I want to show you guys another question that's very similar, and just don't get mixed up with this. So suppose we want to find the derivative of f of theta if this question was equal to cosine, and then if we have a 2 right here instead, and then theta. This and that, they are very different. Because this notation means we have cosine, theta inside, and then the square is on the outside. Alright? So now let's see. If we differentiate this, the outer function is this to the second power. We will have to bring the power to the front and then minus 1 first. And we will get 2. And then the inner function stays the same. We have cosine theta. And again, this will be to the first power. Okay? And then we look at the inside and we multiply by the derivative inside. The derivative of cosine theta is negative sine theta. So that's how it will look like for this case. And again, let's go ahead and just draw the box to help us out. For this case, we will have a box square. So that's the outer function. And then the inner function is the cosine theta. And now we see that if we differentiate this, well, the derivative of a box square is just 2 box to the first power. And if we differentiate cosine theta, this will give us negative sine theta. And then we can just put this in the box, and that's exactly what we have here. And then we multiply by negative sine theta. And for this one, we are going to just put the negative in the front, and then we have 2, and then cosine theta to the first power, and then times sine theta. So this right here will have been the answer if the question was written this way, right? So be sure you know the differences.